So good morning everyone. This is a BEE simulation project of flashy Christmas lights. Today's agenda. What we will learn. We will learn about transistor, which type of transistor we are going to use, uses of transistor and interfacing it with LED in multisim. About me. I am Raj Bitwa, student of BTech ICT department, Marwadi University. So basically what is transistor? Transistor is a semiconductor device used to amplify or switch electrical signals and power. Because the controlled power can be higher than the controlling power, a transistor can amplify a signal. Some transistors are packed individually, but many more are found embedded in integrated circuits. A bipolar junction transistor. There are two types of transistor, which have slightly differences in how they are used in a circuit. A bipolar transistor has terminal labeled base, collector, and emitter. A small current at the base terminal can control or switch a much larger current between the collector and emitter terminals. So which transistor we are going to use? We are going to use NPN transistor. A bipolar junction transistor is formed because of connection established between two N types and one P type in the middle of it. So this is the symbol of NPN transistor. The upper part is called collector terminal, the lower part is called emitter terminal, and the center part is called base. Some uses of NPN transistor. The applications like switching mainly make use of NPN transistor. The amplifier circuits include an NPN transistor. The temperature measuring sensors utilize the NPN transistor. And for high-end frequency applications, this type of transistor is used. Now interfacing it with LED in multisim. So this is the circuit which I have created in the multisim. It consists of 4 resistors, 2 transistors, and 2 capacitors. Because this is a project of flashing light, we have also 4 LEDs, 2 on this side and 2 on this side. Now let us split circuit in half because the two slides are identical. The transistor Q1 is controlled by the resistor R4 and C2, and the transistor Q2 is controlled by the capacitor C1 and resistor R2. For simplicity and understanding, we can represent the transistor as a switch between the collector and emitter and base as a diode, which have same behavior. When powering up the circuit, both the transistors are open. The base of the transistor have threshold voltage of 0.7 volt. Below that voltage, transistor will remain open at the collector. At the collector, the transistor voltage will be the supply voltage. The resistors which are in the middle are much higher in value than the outer ones. As you can see, R2 and R4 is 3 kilo ohm and R1 and R2 is of 100 ohms, which are serious resistors for these LEDs. Because of this, it will take some time before the capacitor is charged up. The charge will start building up now because the acceptable variant for any special value to achieve a proper function, one side of the circuit will be always be slightly quicker than the other. After some time, one capacitor will reach to the threshold voltage of 0.7 volt. This causes to the transistor to be powered up and LED on that side will light up. Now, when LED light up, before the switch closes or transistor is powered up, the voltage at the collector is supply voltage and the voltage at the negative side of the capacitor is near about 0.7 volt. Now, over the capacitor, there is a voltage difference of the supply voltage minus 0.7 volt, that is VCC minus 0.7 volt. In the direction of the transistor, the collector, now when transistor is charged up, the voltage at the collector becomes 0 since it is connected at ground. Now at the other side of capacitor, the voltage will become negative. It happens because let us our supply voltage is 12 volts. So 12 volts minus 0.7 is 11.3. Therefore, 11.3 is the voltage over the capacitor in the direction of positive side of the capacitor. Now, when the positive side of capacitor is connected to ground and the voltage difference over the capacitor remains, causing the voltage relative to the ground becomes minus 11.3 volts. Because of the negative voltage at the base of the transistor will remain as it is. It means it will not get charged up. Meanwhile, the current is still flowing through resistor. This causes the capacitor to charge up again, and the voltage will rise towards a positive level until at same point it reaches to 0.7 volt. This causes the other transistor to become active, closing at that side. So at this point the base reaches at 0.7 volt and transistor becomes active and LED lights up and voltage at the collector drops to zero voltage, and the capacitor have built up the charge of 11 volt, leading to negative voltage at the base of the other transistor. This causes the transistor to stop conducting and become deactive again, and LED turns off. So this was the process of the LED which turn off and on. Now let us simulate in the multisim. See, as you can see, the LED 1 and LED 2 lights up, the LED 3 and LED 4 will be turned off. So the blinking will happen. So this was my project of simulating flashy Christmas lights in multisim. Thank you.